So number 10 is asking me to solve this cube root. So my radical is isolated, so I can just go ahead and cube both sides. So I get the cube undoes the cube root, so I'm just left with what's inside, 4x plus 7. 4 cubed, that's 16 times 4, 64. And then I'm going to subtract 7. I get 4x is equal to 54. No, 57. So I'm going to divide by 4, divide by 4. That fraction doesn't reduce, so I'm just going to leave it as a fraction. 57 divided by 4. You can kind of estimate that with a decimal. 57 divided by 4. You get 14.25, which that's actually exact. Now I have a sort of real life question about cube roots. So it's saying the shoulder height in centimeters of a particular elephant is modeled by the function h of x, or h of t, is equal to 62.1 times the cube root of t plus 76, where t is in years of the elephant. So it's asking how old is the elephant when the height is 280 centimeters. So I'm given height, and I'm asked for t, so I'm going to set this equation equal to 280. So I need to isolate my radical. So I'm going to subtract 76 from both sides. I get 204 is equal to 62.1 times the cube root of t. And I need to divide by 62.1 on both sides. So that cancels. And I'm left with the cube root of t is equal to 204 divided by 62.1. I get 3.285. So I'm going to say 3.29. I need to cube both sides. So t is equal to, my answer cubed, gives me 35.449. So I'm going to say 35.4 years. And 280 centimeters is roughly about 9 feet. So according to this equation, it takes 35 years to get about 9 feet. That seems like a rather long time. So number 12 is asking if the parent function f of x equals x cubed, and it's transformed into 3 times the function of x minus 2 plus 5, what is the transformation to the parent function? So this is function notation, so I don't really know what my function is. I know it has to be some kind of like a cubic, and it's shifted, but I'm not given an equation. So I can create an equation, or I can just look at what's going on with these numbers. So I know x is being shifted to the right 2. It's x minus a positive 2. And that 3 on the outside is greater than 1, hopefully. So it's a vertical stretch by a factor of 3. And that 5 is positive, so I'm adding 5 to all my y values, so my y's are shifted up 5. So number 13 is asking me to find the solution to the equation. So once again, I have to solve it. So I need to get my term with my exponent by itself. So I'm multiplying by 5, so I'm going to do that by dividing both sides by 5. And I get x plus 4 cubed is equal to negative 8. So to undo that cube, I'm going to cube root both sides. So that cube root undoes that cube, so I'm just left with what's inside, x plus 4. The cube root of -8 is -2. So I'm going to subtract 4 from both sides, subtract 4. So x is equal to -6. These don't have extraneous solutions, so that's my solution. Now I'm asked to graph and describe the transformations. I don't really need to graph it first, so I'm going to just go with my transformations. That 4 is on the inside, and I'm adding 4. It's the same thing as subtracting -4. So my shift is to the left 4. So left 4. That 2 is a whole number. It's bigger than 1. So I'm stretching my graph vertically by a factor of 2. That -1 is outside of everything, shifting all my y values down 1. So I'm just going to go to y1, clear these out, put in 2 times the cube root of x plus 4 minus 1. And I'm going to look for some nice numbers. So 4, 3. 1, 2, 3, 4. 1, 2, 3. -3, 1. -3, 1. -4, -1. -5, -3. And 12's off the graph, so I'm going in the positive direction. 4, 3. I got that one. And that's off my graph. So I'm going to go to graph. Oh, I need to zoom out. Zoom 6 gets me back to my standard -10 to 10. So I can kind of get an idea of what my graph should look like. Good enough. 15 is a little bit more complex. I have a cube root and a cube in my equation, but that's not anything too hard for us. I'm just going to dive into it. I need to get my term with the cube all by itself, which is all of that. So I'm going to add 9 to both sides. So that cancels. I'm left with 45 minus 9x to the 1/3 power, which is the cube root, plus 15, all that cubed, is equal to 11. So I'm working my way inside, so I'm going to cube root both sides. And I get 45, I don't need that parenthesis anymore, 45 minus 9x to the 1/3 plus 15 is equal to the cube root of 11. I'm not going to worry about writing decimals out. I'm just going to keep it in the exact form for right now. Then I'm going to subtract 15 from both sides. And I get 45 minus 9x to the 1/3 is equal to cube root of 11 minus 15. And make sure that I'm not shoving that -15 inside my cube root. So I can kind of draw a little line going down, let me know that it's only 11 on the inside. Now I need to undo that 1/3 power. So I'm going to raise it to the reciprocal of 1/3. That's 3. So I'm cubing both sides. So I'm left with what's inside. 45 minus 9x is equal to all that stuff cubed. So now I can subtract 45 from it, or I could just move these around. If I subtract that, it's going to be over here and it's going to be negative. I'm going to add 9x to the other side. So these just kind of switch places. So I have 45 minus all that horrible looking stuff is equal to 9x. So I have x alone, almost, and just divide by 9, and I get x. So now I'm going to go in the calculator and put all that stuff in. I'll be really careful about my parentheses. So syntax is extremely important. So I'm going to do my first set of parentheses, 45 minus parentheses, math 4, cube root 11, minus 15 cubed. And close my parentheses. And then that's my whole numerator, so I can close parentheses, divide by 9. And I get x is 236.7. And I shouldn't have any extraneous solutions. That's my only solution.